All right, folks, let's do some inverse relations here. Well, there's good news about this lesson. There's a procedure here. See, math is sort of broken into two kinds of things. Some things are like you really got to understand what's going on to be able to do this. Transformation is kind of like that. You got to get it, or good luck. Then there's things that are like operations, like quadratic formula. When you first see it, it looks like completely confusing, but there's a set of steps. Do this, then do this, then do this, and everything will be fine. That's what inverse relations is like. It's got a set of steps to it, and my job is to explain those set of steps so you can take any function and do the inverse of it. And I'll teach it like you haven't seen it before, and if you have seen some of this before, then it'll be a nice review. Recall that the inverse of a function is a function that undoes f. You've been doing inverses the whole time in math. By the time you finish learning about addition, you're getting ready to learn subtraction, because subtraction is the inverse of addition. They're tied together, addition and subtraction. You can use addition to solve subtraction problems. Then you learn about multiplying. Coming right after is dividing. They're locked together. You can use multiplication to solve division problems. You know, like they're right locked together. Then there's squared and square root, cubed and cubed root. There's all these things that undo each other. That's what we're talking about here. We're talking about undoing a function. And you use these when you're solving equations way back when. It was always undo. You want to undo adding, you do subtracting. You want to undo multiplying, you do dividing. Okay? So when we talk about inverse, we're talking about the function that undoes f, and we use a special notation. We use a little -1. It looks like a exponent. And at first you're like, well, how am I going to know the difference when it's an exponent or when it's actually talking about inverse? And the answer is you'll be able to tell by the nature of the question. That actually doesn't come up as a big confusion thing. So just have some faith that you're like, oh, apparently something about the questions, I'll know whether I'm talking about an exponent or an inverse. Okay? So when we want to write inverse, we use a little f with a little -1. Example. The inverse of the function f at x equals x minus 7. This function, okay, this is the whole lesson right here. If we get this down pat, the understanding of inverses is already over. Then we just need the procedure. Okay? This function says, take x's and subtract 7. The opposite of subtracting 7 is adding 7. So the inverse function of this, f inverse, is take x and add 7. It's weird looking, I get it, because there's all these x's and everything going on. But all we're saying is, the opposite of subtracting 7 is adding 7. The inverse function to subtracting 7 is adding 7. Now, if you remember inverses from grade 11, you're like, wait a minute, there's a set of steps here, and you're skipping all the steps. I'm like, no, I'll get to the steps. Yeah, I know there's a set of steps to handle these things. But I'm just trying to talk about the idea of what inverses are all about. The inverse of the function f at x equals 4x plus 3. It's a little more difficult. This function says, multiply by 4, then add 3. If I'm going to do the inverse of that, I've got to undo adding 3 first, which means subtract 3. And then I got to undo multiplying 4, which says divide by 4. And I've got to do it in the reverse order. This function says multiply by 4, then add 3. My job, subtract 3, divide by 4, if I'm going to do the inverse of that. And if you're a little confused because you remember the inverting way of grade 11, yeah, I got your set of steps coming. Don't worry. But for now, I really want you to understand what this is about. You want to do the inverse of multiplying by 4, add 3. Then you've got to subtract 3 first to undo what was just done. And then you've got to divide by 4 to undo what was done first. You've got to reverse it in the reverse order. Since the inverse of a function undoes or reverses the function, recall the domain and range are just interchanged. Maybe it's not recall. Whatever the inputs of one function were become the outputs, and the outputs become the inputs. Because we're inverting things, the x's become the y's, and the y's become the x's. We're just reversing the whole thing around. Maybe that's not obvious until I show you some graphs. You've got this in front of you, yes? Minimal copying on that first page. Is that right? Okay. Therefore, we can find the inverse of a function by exchanging the x and y coordinates. Oh, that gets the highlighter. Highlighting on PowerPoint is very difficult, but I'll make the effort because that's such an important line. We can find the inverse of functions by interchanging x and y. What I mean by that is you're interchanging What's the input and what's the output? You're just exchanging the order of things. Need more time to do the highlighting? That's why I love Staples. My daughter, when I take her into Staples, every time, she's in second year university, and every time we go in there, she's got a pack of highlighters she wants me to buy for her. Because she highlights everything. Everything's like, highlight this, highlight, then she's got a coding system, you know. Green's for, got to know this for the test. Pink's like, I don't understand. Yellow's, ask the prof. You know what I mean? That's got a whole system going there. Here's the steps. Here come the steps. You're like, tell me, what do I got to be able to do here? This is what you got to be able to do. And this is a reasonably difficult one. So this is a good prep for a test type question on inverses. It says find the inverse of f at x equals square root of 2x minus 1. Very carefully writing all the steps. First, write f at x as y. It's early in your career with dealing with f at x, and it might just seem like a pain to have things that are just f at x at this point. I totally get it. That's the way it probably seems right now. But sometimes f at x will be better, sometimes y will be better. What I'm saying in this particular situation, algebraically, you'll like inverses better using y instead of the f at x. So I put a y there. Now, here's the really big step. I'm going to put a little 1 there for step 1. Step 2. Exchange x and y. This is the inverse step. This is the step that turns this thing into its inverse. We want to reverse the whole procedure. We're just reversing x and y. We're changing which one is the input with the one that was the output. Technically speaking, that's the inverse right there. We've got the inverse there. I'm going to do some extra steps here, but I've done the inverse at that moment. Is this ringing a bell from grade 11 at all? Oh, so some of you have seen this procedure a little bit. If you haven't, that's okay. I'm trying to teach it like you haven't seen this at all. 3, solve for the new y. There's a y now buried deep inside this function, and I've got to solve for it. And I'm going to solve for it by using inverses. That is, the right-hand side over here has a square root. So I need to move that square root over to the other side, and when I do that, it becomes its inverse. That's exactly the same thing as we said in grade 9 when we were solving equations. Adding becomes subtracting, multiplying becomes dividing. We might not have said the word inverse all the time, though. We had to make it more basic for you back in grade 9. Now we say, okay, square root, when you move it over, becomes its inverse, which is squared. That is a great way to think about equation solving. When you move things over, do the inverse, do the opposite. Next, trying to isolate y here. I'm solving for the new y. I want to get rid of subtract 1. I want to move subtract 1 over there. The inverse of subtract 1 is add 1. And finally, there's a multiply by 2 there. I want to do the inverse of multiplying by 2. And the inverse of multiplying by 2 is dividing by 2. There, I've completed step 3 of finding inverses. I've solved for the new y. Step 4. Do you see what I mean about there being a procedure? You do this, you do this, you do this. These kind of questions are nice on tests because if you're prepped, you're like, oh, there it is. There's the inverse question. This one I got. I don't have to think. I don't have to try and process or what function am I dealing with, all that kind of stuff. You just do the procedure. But do you have questions about the procedure? A little more explanation on what's happened here. Originally there was this y and x, and when I exchanged the x and y, they really became a new y and x and all that. Technically it sort of feels like cheating. You're like, well, what happened to this y and x? You're like, I don't need them anymore. They're gone. Yeah? I've got a new y and x where I've changed the roles here. I've inverted this whole situation. I've reversed the x and y. I've made y's x's and I made x's y's. And when I made x's y's and y's x's, I got this equation. But it's not nicely solved for y. We saw one yesterday where it wasn't nicely solved for y, and then it's difficult when it's not nicely solved for y. So I just nicely solve for y by using inverse functions. So the opposite of, listen to this. This is when the understanding really comes. The opposite of multiplying by 2, subtracting 1, and square rooting, that's what this says to do, multiply by 2. Let me just make that list. This function says multiply by 2, subtract 1, square root. That's really what this function says to do. Take your x value, multiply it by 2, subtract 1, and then square root it. The inverse of that says square, add 1, divide by 2. Do you see how that's doing the opposite things in the opposite order? The last thing we did here was square roots. The first thing we do is square. Subtract 1, add 1, times 2, divided by 2. This is just an algebraic way to sort this out. In fact, if you're really good at inverses, you could have done this question by going, this function says to multiply by 2, subtract 1, and square root. So I need a function that squares, add 1s, and divide by 2, and that's what the function is. You see? But these algebraic steps are just like, let me figure those out without having to bend my brain. Yeah? Either way works, though. Questions about that? It's all there in the PowerPoint. Yeah? I wrote it all out because I wanted to talk about each step as I went. But when you go to watch that PowerPoint, if you want to watch it online, it's all there. It's easier with ordered pairs. With graphs and ordered pairs, it's so easy because you only need one step in the whole procedure. Let me put a big circle around it. The important step in this whole procedure. Go back and put a nice circle around that, or a little green highlight, or I don't know what, whatever coding system you got. You're like, oh, I don't have a coding system yet. I just underline stuff. Exchange x and y is the most important step of all that. And so when you've got some points like this, and they say, find the inverse of these points, you just exchange x and y. You're going to look for a trick here. You're like, is it really that easy? Yes. Finding inverses of points is just that easy. -2, -8 becomes -8, -2. 0, -2 becomes -2, 0. 3, 4, 4, 3, 4, 7, 7, 4. You just literally invert the x and y on those points. I think that list of points is on your next page, is it? Or on the next slide? So if you need to copy it from there, you can get it. And then they ask you to graph these points. So I'm going to graph all those points on there because apparently there's something about the graphs that's interesting. Yeah? So I'm going to graph the f's in blue. Here they come. -2, -8, 0, -2, 3, 4, and 4, 7. I graphed all those blue points, which were the f points. Then I'm going to graph all the inverse points. I'm going to graph those ones in red. If you don't have a colored pencil to do these, do the f's with dots and do the f inverses with little x's so you can see the difference between f and f inverse. If you've got another color works good too. So those points are -8, -2, -2, 0, 4, 3, 7, 4. Okay, so if you've got any brain power left after another long advanced function stage, this is the moment that you need that brain power. What I'm going to do is I'm going to talk about each of these individual points and what's happened to them. I'm going to draw this line on the page. Now, the reason I'm putting the ruler up there is so you can see that it's a straight line there. PowerPoint doesn't give me great ways to draw a straight line. I'm going to do the best I can to draw a straight line across there, okay? I'm going to do it in a different color though. I'm going to go with, let's see, pointer options, ink color, something in a green, sort of Christmassy, yes? Oh, well that's as straight a line as Mr. Todd ever does. Oh, ooh, little speed wobble there, up there, okay? Hopefully you can draw a straighter line. Maybe you got a ruler available to draw the straight line. Now take a look at these points. The point -2, -8, which was there on the original function, went to here. And I'm going to draw it really weird so you can see what's happening here. -2, -8 came to -8, -2. Hello! Yeah, she is. Certainly. Do you see what happens there? That point has gone to there. You're unimpressed until you see what happens to the other points. This point here went to there. This point here on the other side went to here. And this point here went to there. It's like they got spun or reflected on this line y equals x. The line y equals x flips them over. I don't need you to know much more about that except, well, that's kind of neat. It sort of reminds you of odd and or of an even function, but it's even across this line y equals x. It's exchanged over the line y equals x. There's a little more of the story here in later grades, but for now it's enough to go, well, isn't that kind of neat, the way they've sort of flipped over the top there when you take the inverse. The y's become x's and the x's become y's. If you're really with me visualization-wise, xy, the axis xy has become yx, and that's what flips that over there. You don't need to know all that. Here's what you need to know. Those become those. Yeah, that's enough for now. I think the next slide just explains that in more detail. It just says, how are the graphs of f and f inverse related? They're a reflection along the y equals x. Looks like he's green there too. Was that in my brain? I don't know. It's hard to tell what's in my brain anymore. So that's all dramatized there for you as well, but I wanted to do it live. Why does this relationship make sense? Maybe it doesn't. It's difficult to see why it would make sense, why you'd be reflecting over the line y equals x. With this line y equals x, it's really you're just taking the x-axis. Do you see my thumb and finger along the x and y-axis? You're really taking the x-axis and making it the y, and the y-axis making it the x, and you see how that results in this weird flipping action over the line y equals x. For the inverse of a function, the x and y coordinates of each point are the original. Oh, yeah, that's so good. That gets the, I'm going highlighter crazy here in the last part of the day. For the inverse of a function, the x and y coordinates of each point in the original function are interchanged. The domain and range get interchanged. The inputs become the outputs become the inputs. Last example coming up. Squeeze one more into your brain. You're like, no, this stuff's been oozing out for an hour. You can keep pushing things in my brain. Stuff's just coming out the other side. One more example. Find the inverse of f at x equals x squared plus 2. If you're right with me, you better check this out. This one's got a little quirk in it. Doesn't seem like a big deal. Quadratics you've done many times before with x squared and so on, so you think there's no big deal here. But there's one little step here that'll drive you nuts if you don't really get it. Okay, here's the steps. They give you a function f at x equals x squared plus 2. I'm going to try and match up these steps with what I wrote before. Step 1. Yellow, okay. Step 1. Write it as y equals. Yeah, that was step 1, what I said before. It's going to be easier to work with y than with f at x in this. Step 2. Exchange x and y. I'm trying to match those steps up with what I wrote on the previous page so you can look back on those steps if you need to. Step 3, solve for the new y. You've got a new y over here, and we want it to be y equals. So solve for that y. So to do that, we first do the opposite of adding 2, which is subtracting 2. And here's the big moment. The opposite of squaring. It's square rooting. You're like, why is he making a big deal about this? Squared, square root. We've been doing that since Pythagorean theorem in grade 7 and 8. Not a big deal. Oh, good. Saw the frowns. Good for you, you frowners. Thank you. Let's get sidetracked for just a second. When you first learned about squaring, it was Pythagorean theorem. And we got something like c squared equals 25. And we wanted to know the length of the hypotenuse or something like that. So all you learned was c is the square root of 25, c equals 5. And that was right back in grade 9. But if this doesn't come from the Pythagorean theorem, and this says c squared equals 25, it's saying find all the numbers that when you square them, you get 25. Well, 5 squares to give 25, but there's another number. What's the other number that squares to give 25? Negative 5. So when we're doing square roots in general situations, we got to do plus or minus because there's two answers that come out of that. That's where that plus or minus comes from in the quadratic formula. You know, negative b plus or minus the square root of b squared minus 4ac. There's this plus or minus comes out of it because square roots always give two answers. So here I get plus or minus square root of x minus 2. Why is that such a big deal? If I were to graph this thing, and maybe you got to do your transformations homework before this becomes easy, but this is a square root function moved right to, there it is. But to be truly the inverse, I need the plus and the minus, you see, to get both sides of the curve. That's why the plus or minus is so important there. Was I a truth teller? That was pretty quick, was it, that lesson compared to the other lessons? And there was really no extra place to go with all that. So I didn't skip over anything. I didn't rush it. But do you have questions about what happened on that slide? A separate function, what do you mean? I'll let him look that up. Other questions though?